Section 6, Ideal Gas Law for the Ideal Toy. Chem Talk. Ideal gas law. Temperature, pressure, and the number of particles must be considered when talking about a gas. An ideal gas is defined as one in which all collisions between atoms or molecules are perfectly elastic and in which there are no intermolecular forces. The molecules per atoms of an ideal gas have no volume. You can picture the ideal gas as a number of perfectly hard spheres that collide but that otherwise do not interact with each other. Many common gases exhibit behavior very close to that of an ideal gas at high temperature and low pressure. In spite of their different masses, all ideal gases have similar characteristics as shown in the below table. Note, molar volumes of real gases vary a little, but they are close to the molar volume shown in the table. As examples, a mole of chlorine gas, 22.1 liters, and carbon dioxide gas, 22.3 liters, are a little less than the volume of an ideal gas, which is 22.4 liters. You can think of a real gas as being close to an ideal gas under standard conditions. This is due to attractive forces. The ideal gas law relates the pressure, temperature, volume, and number of moles of an ideal gas. The ideal gas law was originally derived from the experimentally measured Charles's law, Boyle's law, and Avogadro's gas law. The ideal gas law states, P equals pressure in atmospheres, V equals volume, as we know, N equals the number of moles of gas, right here, R equals the universal gas constant, which is this, and T, as we know from the previous section, is temperature in kelvins, right there. Notice that R values differ depending upon the units of pressure, volume, temperature, and mass of the gas. However, the preferred and most convenient units are liter, atmosphere, moles, and kelvins, in which R has the value of 0.0821 liters times atmosphere divided by mole times Kelvin. Okay, let's look at this. Example. The ideal gas law can be used to make predictions about the pressure, temperature, volume, and number of particles of a gas. For example, you might want to find the pressure of 2.5 moles of hydrogen gas at 25 degrees centigrade if its volume is 8.55 liters. Using the PV equals nRT, rearrange the equation to solve for pressure. Pressure equals divided by volume. So now we're going to substitute these values in here. Okay, here we go. All right, so pressure, which is this. Okay, the nRT. So we're going to take the moles, the liters times atmosphere divided by moles times degrees in Kelvin times the degrees in Kelvin. And then you're going to divide that by the volume. So in this case, the pressure equals 7.2 atmospheres. By using the ideal gas law, you are able to make predictions about the behavior of a gas based upon data you have measured.